I need to reopen back. So latch, unlatch. So let's go ahead and download this. See if I- let's go ahead and download this. Let's see if I can slide it over. So it did pop up. It was down here at the bottom, but it's on the wrong side of the taskbar. I'll see if I can figure out later on how to do this. So the way this guy is looking, so I've got this start stop station. It's not starting a motor. It's just what we call a master start stop that would stop the whole system. Does not need an output. What it's going to it's just going to disable all the runs in my program, which is really common. So this would be something like an e-stop button could do this. So if you hit e-stop, what you want to do is you want to kill everything in your system, right? Well, this would do that. So you notice I've got this B. So this is switch 1, switch 2, and then these were used in. I'm sorry, I can't do that. So this is okay. I'm gonna have to reassign this guy down here or up here instead of using this. So it'd be easier to use this. So let me see what's in my tag table. Okay. Okay. So we'll find this to put 0 slash using 1 and 2. So here I'll use 3. I don't see where I'm using a 3 up here, yeah. Today is just some of that. Okay, there we go. So it didn't switch me online. So I'm gonna come over here and I need to switch to close. What I did is I just latched it. So what I had to do before anything happened, so I could, and then I'll come over here and I'll switch 3. So I'm gonna over here switch 3. So 0 is what? Latched it. Now it shows both of them true. And why is that? So this is the same address, right? You understand? So here, this is output 0. This is output 0. So these guys have got to be used in pairs, which means if you use a latch, somewhere you got to do what? You got to have an unlatch for the same output or whatever you use. Motor. I got this hooked up to a motor on my little panel there. And like I said, I didn't dream it back up. So what they did on the Festool line is the whole sequence, since it didn't need to generate an output till it figured out what was going on, they used latched and unlatched, and then they used B3 files because they didn't need an output, right? You understand that? So we call these internal cores, which means they don't use one of your what? They don't use one of your outputs. So if I've got a coil that does not need to turn on the light, it does not need to start a motor, it does not need to energize, then we'll use what we call an internal coil. And this is the big advantage of a PLC. So if this was relay logic, I would have to have what we call a control relay. We call them control relays. These are relays that never leave the control circuit. Their contacts never leave the control circuit. And these are the relays that the PLC basically takes away. So we don't have to have a real relay anymore. So yeah, if you take motor control, you'll see that we have these control relays, and they don't do anything but do what? They don't do anything but control. They just make decisions. So this is latch and unlatch. It's a really powerful instruction. Takes the place of a lot of these. So I could do the same thing. I could do the same thing with this thing up here. Yeah, that's exactly what it is. It's a lock-in. We used to have out at US Steel, they had a lot of radio controlled cranes. So this guy would be down on the floor running this big old 40-ton crane, huge. It was always amazing. We worked on those. And one of the things that they could hook up was a big old magnet. The problem is though, if something happened, if they lost reset, then if the magnet was carrying the load, it would turn off. So what they did on that is they put what we call a latch and relay, which does exactly the same thing. So once they latch it, even if they lose reset on the crane, that magnet would stay energized until they could release it. So this was basically sort of the purpose of what we call latching and unlatching relay. But you can see the power of it. Like I said, I could figure out how to do the same thing with this fill-in circuit right here. So I would seal it in, and then somewhere down the line, I would break it. Instead of using a stop button, I would break it. I could do the same thing. But look how much logic it takes when this right here just takes just one relay to do it. And so it does the same thing. It basically is this circuit right here. So I could do the same thing. So I could come over here and have one of them I call start, and then one of them I call stop. I could do it with latching and unlatching, but that's not the feature. It's these sequencers that we set up, where we say, okay, we latch it here, and then maybe in the next sequence we unlatch it, right? And we just go right down the line. But anytime I'm going to put a contact, if I'm going to put contacts that's controlled by a relay, But I don't need an output. I'm not going to sacrifice one of my outputs. I'm going to use what? I'm going to use one of these big three files. Uh, Siemens they call them memories. They call them memory bits because that makes more sense to me because these are coils that in the memory of the PLC. But all these PLC programs supports these internal coils. And 90% of a big control circuit, 90% is these relays that just make decisions. They don't need to turn on the motor. They don't need to turn on the light. But in control logic, we would have to have a control relay in there that does that. So PLCs replaced all the control relays in a program. They don't replace all relays, but they don't replace the power relays, the relays that actually run motors and stuff like that. But they definitely can replace these. Just in the program, they're in the program. They're not really real. They're just there. But the ladder logic responds to it like they're real. Another thing I wanted to show y'all that's in this chapter, I won't go back to the PowerPoints. It's something that's really neat, but it could kill people. So what we have the ability to do is we have the ability to do what we call force contacts while you're online. So right now, to get this guy right here to come in, to energize, I would have to come up here. Let's say this output right here. In fact, let me just open up another file. So these are all the programs I have on my server over there. So this is just a standard stop. This will be easier to show y'all this. And I can always redraw this. So this is just a standard start-stop. And what this is pretty powerful. You know you can create programs without having a PLC connection. So this gives us the ability to. This is a troubleshooting aid if it ever loads in. That allows us. It's probably been faster to just create a new program. So. And the other one might not work anyway. It might be, today just isn't my day. We're offline. And we'll say, yeah. It'll come over here. I think I was answering the question. I'll put it like I didn't read it. Did I ever do that? Think something says something. Okay. So what I'm gonna do is just create just a basic start-stop station. It'll come over here and set up a new run, right? Come up here, go down to there. Go down there. Put 0/0/. So here, if we look at our project tree, we'll see that inputs are actually in data file 1. But we can't have multiple of these. These are set by the hardware, so that means if you put input, it automatically uses data file 1. So we don't have to specify the data file. Even though I'm pretty sure I could call it input : 0, input 1, data file 1, 0/0, and it still works. So it knows where your input is. So we don't have to tell it where the input is. You gonna tell everybody what's on your phone there? It's so interesting. It's more interesting than we'll assign this to, we'll actually force an output so y'all can hear it. So output colon, and I got the motor hooked up to output, output colon 0/0. That's where the motor's hooked up to. So y'all can actually hear it run. We'll call this run. Now we've assigned this contact to an output, but I can go ahead and give it to, and then I can come over here and use that. See? Do it. And then we'll assign this to input 0/1. We'll call it stop. You don't have to be stopped. Okay. We'll check for errors to see if it's okay. And then we'll download it. Give it a name. By the way, you can save it as untitled if you want to. Go online. Okay. So I can come over here and I could use my switches to control this one. I still have my push button control. I started running that. So, okay. So I say, okay, I'm having problems with output 0 running. Let's see if it's the actual output. Well, what we have the ability to do is notice force is enabled. So I'm going to come down here, and one of my options down here is force. So I'm going to click on outputs, and this is my force table. So I'm going to come up here and enter a 1. I'm not hitting any push buttons or switches, and I just force that out. If I don't want to force it, I don't put a 0 there. I have to come over and highlight it again. Just hit delete and hit enter, and then I can force inputs. So I can see, technically it's called simulate, but we still call it force. So output 0, I could come over here and on output 1, I mean on input 1, I could put a 0. And then I could come over here on output 0 and I close my force table. I could come up here and now what's the problem with this? You could hurt somebody. Yeah. So you better be sure when you force these things that you understand the consequences of what's going to happen. So you need to make sure everybody knows you're fixing to force that contact, because what you've done is you've taken away every safety feature that's in the system. So it's not going to check to see if sensor 1 is true, which nobody's in the robot cell, right? You understand? If you force that thing, it's going to go down. But it's a really good troubleshooting tool to use. So if I can simulate it here, then that means the program's okay, and it's got to be the push button, right? You understand that? So, and by the way, to take force off, you have to just come over here and actually just delete these, and they'll go back to dot. They're supposed to anyway. Yeah, there we go. I wasn't hitting the enter key. And now it's back being controlled by my push button. So that's forcing. Pretty cool, right? But you can do what? First mode. And by the way, relays, most relays have this feature also. You can't see this on